Okay, we're going to be looking at adding and multiplying rational expressions. Again, this is the addition part, this is the multiplication part. So think of this as three terms, A, B, and C. Because, if you remember BEDMAS, because there's multiplication, we technically have to go in this order first. We're going to deal with the multiplication first, so these two rational expressions. Once we've simplified those two, then whatever new rational expression we have from that, we'll add to this one here. Okay. On top of that, we need to set up our restrictions. There has to be restrictions. We have three denominators here, so I'm going to label them very quickly. We'll call this one red will be A, blue will be B, and green will be C. Okay, I'm going to quickly work with A. So A is equal to B squared minus 2B minus 15. We need to factor this. We can't really make a great restriction without it being factored. Okay, think of two values. Yep. I'm going to quickly do a sum and product factor of this, and it's going to be B minus 5 multiplied by B plus 3. If you check, those two should work out, okay? Are you okay with the factoring of that? Okay. Can equal 0. So, because there's two of them, we got to split the two up.
B plus 5 and B.
Exactly. Perfect. So you did it nice and quick. So we'll just jump to that on the next one. We won't go through this process next time. So B cannot equal positive 5, and B cannot equal negative 3. Wonderful. That's A for us. Okay, I'll attach. So let's not do that. Push it to not attach. B. Same concept. B squared plus B minus 30. 6 and 5 multiplied to 30, and we need to be positive 1. So B plus 6 and B minus 5 will work out wonderfully. They cannot equal 0. We split the two, and we know that B, great, can't be negative 6, and B cannot be positive 5. Hey. And then the very last one, much simpler. C, B plus 3, well, it can't be equal to 0, so we'll turn that into 0, which means B cannot be
equal to negative 3.
Perfect. So you just crushed all the restrictions really, really quickly. That's excellent. So we have 1, 2, 3, oh, that's hard to see, 4, 5. 5 major restrictions. Now we're going to quickly simplify. Okay, let's go to the second part here. I wish there was a fast copy paste here. Okay, so you'll see we just kind of carried over our factor form because that's important for simplifying. We still got to factor this one on top, so we'll very quickly do that. On this page, let's call it D. We'll say D. D is equal to B squared plus 8B plus 12. Two things that add to 8. 6 and 2. Wonderful. B plus 6. B plus 2. Great. Let's rewrite what we got there. We have, and again, we're going to focus on this set first, okay? So this kind of comes down. We have 2B minus 5 over B minus 5, B plus 3. Nice if I can just move this restriction. I cannot. Plus 3B over B plus 6, B minus 5. Because it's associative property, it's multiplication, we're just going to make this one big fraction, okay? So on top, we're going to add our B plus 6 and B plus 2. And on the bottom, we've already written that part, we have B plus 3, okay? This is all one big fraction. I know it's really messy. We're going to simplify it by getting rid of anything that's on the numerator and denominator. So we have this, B plus 6 and B plus 6 can disappear. And it just works out really, really nice because look, our denominator is now B minus 5, B plus 3, B minus 5, B plus 3. We have common denominators. We can go right into adding. So we won't even expand anything. We're going to keep everything in its factored form. This way it's going to be simpler for us to do the very next step. The next step being, I'm going to put brackets around it just so it kind of looks similar to everything else we're working with. Think of each bracket like a package or a box we're working with. B minus 5, B plus 3, and then that's all going to be added to whatever's left on top. So what's left on top? Well, we have 3B, and we have b plus 2 over b minus 5 and b plus 3. Well, because the denominators are the exact same, all we have to really do, oh, that kind of like looks like I erased it. We just have to add the values on the numerator. That's it. So we're going to say this plus all of this over just one of the denominators. Shrink it a little. That's not shrinking anything. I'm just going to find more space. So everything's going to be over b minus 5 and b plus 3. Here we have 2b minus 5 plus 3b, b plus 2. Now, this is technically very, very simplified. They might ask you to expand this, add it to this, and then see if it's factorable again, which it might be, so we're probably going to have to try that. Of course. Okay, so let's quickly expand this. This is distributive property, so we multiply the first and second term within there. We'll get, yeah, I'm just going to rewrite it quickly.
Plus 6b.
So 3b squared, perfect, plus 6b. You know what I'm going to do? I'm going to highlight the top part here. And we're just going to work with the top. We're going to leave the denominator for now. And then once we've simplified the top, we'll add the denominator right back in. So now we have 3b squared. We can drop these brackets. Plus 6b plus 2b minus 5. These two are common. So we get 3b squared plus 8b minus 5. Okay. Is this factorable? Is the question. So you can do a sum and product. We need two numbers that multiply to negative 15.
15.
To 8. Okay, so we quickly factored it off screen. That's the numerator. Let's put it up here. 3b plus 5, b plus 1 over b minus 5, b plus 3. So the hope was that we get another thing that could cancel out. Wasn't the case, but this would be your most factored version of it.